All right, here's section 8.2. We are going to use matrices to solve our systems. And the nice thing about this is after you can prove that you can do this by hand, you're going to get to use your calculator for it. So guaranteed you're going to get one by hand, so pay close attention on what we do here. So we're going to look at what's known as the Gauss-Jordan method to solve systems of linear equations. And the concept here is removing the variables and putting in the coefficients of all the values into a matrix, and by their alignment we know what they stand for. So to set up an augmented matrix, all right, you have what is known as an augmented line. This represents the equal sign. Your constants go on the right side. Your x terms, y terms, z terms, they're going to line up by columns. All right, so my 3, 9, 6, 3 will let the x represent the first column, y the second, z the third, and the last on the right side of the augmented line will be our constant. When there's no coefficient there, again, we'll put in 1s, so we're going to have 2, 1, negative 1, 2, 1, 1, 1, 2. Now, what we want to do is we are going to do some matrix row transformations. So let's talk about that for a little bit. So what we can do is you can interchange any two rows. So I could say, oh, here's row 3. I want to make row 3 to be row 1 and move row 1 down to row 3. So you can switch rows anytime you want. Next, we're going to multiply or divide the elements of any row by a non-real zero. You've done this before. Remember when we multiplied an entire equation by 2 or negative 2 or divided it by 3? Same rule, same thing. Number 3, this is the one that's different. Replace any row in the matrix by the sum of the elements of that row and a multiple of the elements of another row. So what we did here is in the past video, this is where we added the two equations together to cancel out that y or the x, and we created that brand new equation. Okay, that brand new equation is going to replace a row. All right? Now, what we want to do is we want to use what is known as Gauss-Jordan elimination method, otherwise known as a reduced row echelon form. So what we're going to do is we're going to look at what the answer will look like. And we've already solved this system back in 8.1. So this is what we're going to create, a reduced row echelon form. The 1 in the upper left-hand corner, this is the x column. So 1x equals 2. In other words, you have 1x plus 0y plus 0z equals 2. Here's 1y equals negative 1. 1z equals 1. So there is the solution to our system. 2, negative 1, 1 is our ordered triple. Now, how do we get to that? Well, this is where Gauss and Jordan's methods come into play. All right, so quick story time here. Gauss was a German mathematician. Very, very smart, intelligent number cruncher. He could do decimals, fractions, integers, whole numbers, negative, everything in between his ears. He was a human calculator. What Gauss did is he would want to make a 1 right here. And then he would just, okay, if I had to divide by something, so if it was a 3, I divided every element by 3. Boom, 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 I got it. Once he had the 1 here, then he wanted to turn these two numbers, let's say the 2 and the 1, into zeros. All right, well, that's where we're going to multiply something to the first row to get the opposite of what we have here, add it together, and make that new equation where this x had canceled out. And then he would cancel this x. So that's steps 1 and 2 right here. Obtain 1 as the first element in column 1. There it is. Step 2, use the 1 in row 1 to transform the remaining entries below in column 1 into zeros. All right, so if this was a positive 2, you want to multiply this whole row by a negative 2 and add it to everything in row 2. If we got a 1 down here, we multiply this by a negative 1, add it to everything in row 3 by row 1. And then we get our zeros. And then step 3 is you repeat step 1 and 2, but now you obtain the 1 in the second element of column 2. So we make this into a 1. And we'll look at how we can do that. Again, we can do divide by whatever that value is. We can also do some other sneaky techniques where I like to claim there's a Gauss, Jordan, Fitzgerald method, but I haven't published it yet. But I'll show you my sneaky techniques. But again, we're going to make this a 1, make these into zeros. Step 4, repeat, make this into a 1, make those into zeros, and we have our answer. All right, so Gauss was responsible for the zeros, if you will, in the lower left-hand corner. Jordan came along and said, wait, he studied under Gauss and said, well, Gauss, I understand what you're doing. You're taking your answer, back substituting, you're a number cruncher, and you can do all this numerical and number crunching to get to your answers. He said, well, why don't we make the upper right-hand corner zeros? And then you have the answers, and we don't have to do a lot of number crunching to do that when we do our back substitution. All right? So, examples of how to get our ones. Now, granted, these are 2 by 2 systems. I am not going to argue the point. This is for example purposes only, so you can see this technique done. All right? This is how different ways you can make ones. Okay, now, so let's build our augmented matrix. 3, -4, 1, 5, 2, 19. Now, understanding Gauss. Gauss would say, well, 3 needs to be a 1, and the only one to make that a 1 is you have to divide it by 3. That means you divide the whole entire row by 3 or multiply by 1/3. Do you really want to work with -4/3 and 1/3? Gauss didn't care. His brain handled that. All right, we don't like fractions. So here's a technique that I like to use. I'm going to call this row 1, row 2, and I'm going to look for multiples of 3 and 5 such that they differ by 1. All right, so, oh yeah, 3. I could double that to a 6, and then if I subtracted the 5, I would get a 1. And I can have a 1 here, and I don't have any fractions whatsoever. So in order to do that, I have to create what is known as a row rule, telling the reader, me, the teacher, reading the student's work, what is actually taking place. Well, I said I want to take the 2 multiplied by 3, which makes it a 6, subtract the 5, and I get a 1 that I want to put right here. Okay, well, I got to do that to all the elements in each row. So it's not 2 times 3, it's 2 times the 3 in row 1, not minus the 5 in row 2, and I replace everything in row 1, not just this spot. So here we go. 2 times 3 is going to be 6, minus 5 is going to replace that 3. 2 times -4 is going to be -8 minus 2. That's going to replace the -4. 2 times 1 is going to be 2 minus the 19. That will replace the 1. So crunch the numbers. We'll get a 1, a -10, and a -17. There's the changes. Row 2 did not change. But again, I acquired the 1 in the upper left-hand corner, and I have no fractions. That's the goal, no fractions. So now, how do we make the 5 into a 0? This is where you have to add its opposite. Well, the opposite of positive 5 is -5. So I'm going to take -5 times the 1 and add it to the 5. This is where in the past, the last section, we would take negative 5 and multiply it to the whole equation. 1x minus 10y equals negative 17. Move it down below and have negative 5x underneath this 5x, and we cancel the x's. But again, we got to do this to the whole row. So negative 5 times the 1 is negative 5, and I add it to the 5, and I'm going to replace this 5 with 5 minus 5. Negative 5 multiplied to the negative 10 in row 1 is going to be a positive 50 added to the 2. That will make it 52. Negative 5 times negative 17. Okay, we may have to punch that into our calculator to get a number crunch. That's going to be a positive 85. Add it to the 19 in row 2 to make our brand new row 2. This is going to be the new. Once you see this arrow or an equal sign, this is the new row 2. So crunch the numbers. 0, 52, and let's see, 104. Column 1 is now done. When we do get to the lower right-hand corner to establish a 1 here, we have no choice but to divide by 52. Okay, I cheated up here. I used the number below the 3 to help me, use that 5 to help me make this into a 1. Well, there's nothing below the 52, so I just have to divide row 2 by 52. So I can either divide by 52 or I multiply by 1 over 52, the reciprocal of 52. So 0 divided by 52 is 0. 52 divided by 52 is 1. 104 divided by 52 is 2. I did not change row 1. Now, we need to make the negative 10 into a 0. So again, just like we wanted to change this 5 into a 0 below the 1, we want to change this negative 10 to a 0 above the 1. You need its opposite. Positive 10 multiplied to the 1 in row 2, added back to the negative 10 in row 1, will become my 0 now in row 1. And here's the best part. You're going to watch column 1 never changes. 10 times 0 is 0. 10 times 1 plus 10. 10 times 2, 20. 1 plus 0, no change. This is a 0, that's a 3. There's my answer. X comma Y. My ordered pair is 3, 2. All right, now the second example, again, being sneaky. This one hurts. Oh man, there's no, 4 is a multiple of 2. There's no way to make these two numbers to differ by 1. So what do? I get sneaky. Look at the y's. Oh, there's my 3 and 5 again. I can make that a 6. 6 minus 5 can be a 1. So here's what we do. Put the y's first, put the x second. Now, when you do this, you can only do this at the very beginning. So when I do this, I go down to where my final answer is going to be, and I call this the y column. This is the x column. The first answer is going to be y. The second answer is going to be x. So when I do write my ordered pair, I make sure I get my numbers correct for my variables. All right, so I'm going to do the same thing. Let's turn this negative 3 into a positive 6 by multiplying it by a negative 2. So negative 2 times row 1. Again, that's negative 2 times the negative 3 will be 6. Minus the 5 will give me a 1 right there. But again, you have to do that to every element. So negative 2 times negative 3 is 6 minus the 5. Negative 2 times 2 is negative 4 minus the 4. Negative 2 times 11 is negative 22 minus this 11. Crunch the numbers. 1, negative 8, negative 33. It sure beats going, okay, divide everybody by 2. Negative 3 halves, 11 halves, and have to work with fractions the rest of the way. I mean, listen, when we solved this by the elimination method, we would multiply this equation right here by a -2 and cancel this out. Cancel the x's. I get it. Yes, elimination for 2 by 2s is probably quicker and easier. Again, I'm just using this technique to show you how to get a 1 and start out in this upper left-hand corner whenever you need a nice integer throughout row 1 and you don't want to deal with fractions. So we'll continue on. Same step as up here when we had the 1 and the 5. -5 times row 1 plus row 2 will be our new row 2. -5 times 1 minus 5. -5 times -8 plus 40. -5 times -33, what, positive 165. Add the numbers in row 2. There we go. Column 1's done. We need to turn 44 into a 1. Just like we did 52, you have no choice. You got to divide all of row 2. When you're in the lower right-hand corner, you got to divide it by itself. Row 2 divided by 44 is the new row 2. That'll be a 1, and that will be, I believe, a 4. There's my 1. -8 needs to become a 0, so the opposite of -8 is a positive 8. Multiply that to the 1 in row 2. Add it back to the -8 in row 1, and that will be your new row 1. And again, column 1's not going to change because 8 times 0 is 0. 8 times 1, there's my positive 8. 8 times 4 is 32. All right, so we're going to get 1, 0, and a -1 right there. But remember, that -1's not the x, it's the y. And the 4 is the x, so my answer is 4, -1. All right. Okay, next. Here we're going to look at a nice, big, huge system. All right, this is the one I had at the very beginning. All right, whoops. Always reduce your rows or equations whenever possible. So looking at this first equation, divide that by 3 right away before you put it into the augmented matrix. 3 divided by 3 is 1, 9 divided by 3 is 3, 6 divided by 3 is 2, 3 divided by 3 is 1. 2, 1, -1, 2. 1, 1, 1, 2. All right, now, here we go. We're going to take one big stone and hit a couple birds. My 1 is established. This needs to become a 0. This needs to become a 0. So there's my row 1, row 2, row 3. Opposite of a positive 2 is a -2. So -2 times the 1 in row 1, add it back to the 2 in row 2, becomes my new row 2. All right, but again, we got to do that to all the elements. So -2 times 1 minus 2. -2 times 3 minus 6. -2 times 2 minus 4. -2 times 1 minus 2. Folks, write this in there. Do the quick number crunching and put it where you're going to change that value to a 0. All right? If you want, crunch it and move it over. I'm going to wait. As I want to point this out here, a lot of people like to go, well, 1 minus 1. Again, I'm not a fan of that. I prefer what's the opposite of 1? -1. That's what you multiply up here. -1 times 1 minus 1. -1 times 3 minus 3. -1 times 2 minus 2. -1 times 1 minus 1. We crunch the numbers. 1, 3, 2, 1 doesn't change. We have 0, -5, -5, 0. We have 0, -2, -1, 1. All right, now column 1's done. Now we go to column 2, and we got to get the 1 in the middle here. We got to get this downhill diagonal to be all 1s. Well, here we're kind of lucky. Notice that all the numbers in row 2 are technically multiples of a 5, or in this case, -5. So let's just take this row 2, divide it by -5, and that will make a positive 1 right there. That's what we want. So 0 divided by 5, 0. -5 divided by -5, 1. -5 divided by -5, 1. 0 divided by -5, 0. So I'm just going to change my row 2, keep my row 1 and row 3 the same. The 1 is established. Now we're going to turn the 3 and the -2 into zeros, and we're going to do them at the same time, just like we did right here when we wanted to change the 2 and the 1 into zeros. So again, opposite of 3, -3. Here we go. -3 times the 1 in row 2. We add it back to the numbers up here. So -3 times 0, 0. Again, no change on that first column. -3 times 1, -3. -3 times 1, -3. -3 times 0, 0. All right, now let's do row 3 while we're here. Opposite of -2 is +2. Bam, +2 times the 1 in row 2, added back to the -2. That's our goal. But again, no change here because 2 times 0, 0. So after a while, you're going to say, hey, you know what? I don't need to write this in anymore. I'm all for it. 2 times 1 plus 2. 2 times 1 plus 2. 2 times 0 plus 0. Crunch your numbers. 1, 0, -1, 1. 0, 0, 1, 1. Oh, how convenient. Here we are in the lower right-hand column, and we have our 1. All right, so now we've got to turn this -1 into a 0, this +1 into a 0. And folks, please don't do this. Oh, let's just add -1 to this 1 and make it a 0. No, you would have to add this 1 to that 0 and change that to a 1. We never want to see your zeros change. You have to use the 1s in the downhill diagonal. So we're going to go row 3 plus row 1 to be your new row 1. You don't have to multiply. They're already opposites. So 0 plus 0 plus 0 plus 1 plus 1. Now I need the opposite of this +1, which is -1. So I will have to multiply a -1 to my +1 here in blue and add it up to this 1 here. But again, these zeros aren't going to change the 0 and the 1 because -1 times those two zeros will be plus zeros. -1 times that 1, -1. -1 times this one, -1. Crunch the numbers. There we have it. 1, 0, 0, 0, 1, 0, 0, 0, 1. There is my reduced row echelon form. So x equals 2. 1y equals -1. 1z equals 1. That's my solution.